Hey guys, so today we're going to talk about normal distributions. So I just wanted to again determine whether each histogram is normal. So normal means that the distribution is symmetric. So what I would say is see this really nice bell curve. That's like another way to say it. Okay, this is a normal distribution. But this one over here, you can see like I would have to go all the way over here to make this a bell-shaped graph. So this one is not normal. Now, you already know that if it's not normal, it's skewed. So you would be able to say, no, it's not normal. Why? Because it is skewed. And when we would do this, we would have to push that information over to the right, so this would be skewed right. Okay, so what today we're going to talk about, or what like the big question we're going to answer is, what percent of the data lies within 1, 2, and 3 standard deviations of the mean? Okay, so again, I told you that like that standard deviation and the mean are that measure of variation in center that work with a normal curve. And the reason for this is because it doesn't matter what normal curve you're talking about, like what data, if the graph looks normal, it fits this situation, okay? It's saying that if this is the mean, remember that mu, this symbol here, means the mean. If you go within 1 standard deviation, so if you subtract a standard deviation and add a standard deviation, you should have a certain percent in between there. Just like if you were 2 standard deviations, you should have a certain percent. And if you're within 3 standard deviations, you should have almost all of your data, right? If you are outside of 3 standard deviations, you are definitely an outlier. Okay, so what does that percentage actually break down to? So here's where you're going to want to pause the video if you can. This is the percentages that you want to break it down into. So if you're within 1 standard deviation, if I go like this and I'm within 1 standard deviation of the mean, I should have about 68% of the data, right? Now, I could break it down each way and say if I'm down 1, that's 34, and if I'm up 1, that's 34, because it should be even, because it's symmetric, right? So this is what we get for that kind of situation. If you're within 2 standard deviations, you should have 95% of the data, right? That's quite a bit. Within 2 standard deviations, almost all of your data should be in that area. Okay, and again, you break that up into each one. You say, okay, well, that's 13.5 and 13.5 on each side then, added. Okay, now, if you're within 3 standard deviations, you should have 99.7% of the data, right? So if you're outside of 3 standard deviations, you are definitely an outlier. Your data point has no significance. Like, all it's going to do is skew the data. So at that point, you would probably not be able to use this, right? Because you'd have a number that's really pulling the information in a different direction. Okay, so if you have a data point and you want to know, okay, well, how far away from average is it? That's what standard deviation allows you to do. Okay, so that's why having a normal distribution is really important, right? So again, that's skewed. You have to use the mean, the median, and the 5-number summary, because if it's skewed, you can't actually have this representation because it doesn't break down evenly. As you can see, these numbers do. On the second graph over here on this side, this one, you can see that the numbers are very symmetric. Now, it does say this like 0.15 at the very end. It's just saying that, okay, you might have an outlier on that side. You might have an outlier on that side. But most of the time, all of your information should fit within 3 standard deviations of the mean. Okay, I'm just gonna go over those symbols again just once more. If I have this symbol, this means mu, it's a Greek letter mu. It means mean, right? Or you could have it as X bar if you're talking about a sample, right? So those are like the two symbols you'd have for mean. And then this symbol right here, this like circle with a line on it, this is called standard deviation. Now we know how to find the mean and standard deviation. And again, I would use Desmos to do that because it's way easier to do it on Desmos. It won't take as long, especially if you have larger data sets. But most of your problems are going to give you the mean and standard deviation. They're going to ask you specifically, where does it fit within the normal curve? Okay, so your questions are going to look more like this. It's going to say a normal distribution has a mean of mu and a standard deviation of that symbol. I don't remember what that symbol's called right now. I'm sorry. And x value is randomly selected from the distribution. Find p, so find the probability that a number is between -2 standard deviations and the mean. Okay, so what you would do here, that's what this means, probability of -2 standard deviations. It says mu minus, I should probably erase that and fix it. Okay, probability of mu minus 2 standard deviations is saying 2 standard deviations on that left is less than or equal to x, which is less than or equal to mu. What I would do then is I would go here and say, okay, well, this is right here is -2, and here is mu, here's the mean. So how much of the information should be in that section? Well, I'm going to say that 34.1 plus the 13.6, sorry, and that's what I would get. I would get 47.7% of the data should be in there. So what's the probability that your number, like your data point, is between those two sections? Well, about 47% of the time you'll get somebody that's in that section, right? It's kind of interesting. So we have something, you will have ones that look like this where they've got that probability here. If I change this to my highlighter, that look like this. That's how they're written it out. That's how they've written it out. But a lot of the times you'll have it where it's just numbers, right? So we're used to seeing something more like this example. We're saying, okay, the score of the state's peace officer standards and training tests are normally distributed with a mean of 55 and a standard deviation of 12 from 0 to 100. So they're saying that the tests are normally distributed. You have some people who score really high. You have most of them who get average, like C's, B's, C's, or whatever. And then you have some of them who get D's, F's, right? So that's like a normal distribution. That's kind of how these things are based off. It says, what percent of people taking the test have scores between 43 and 67? So this is where what I would do is I would fill in those numbers where they are. So the mean is 55. So I would put a 55 here because that's the mean. And now for if I'm going 12 numbers, if 12 is a standard deviation, I would do 55 plus 12. That's going to be this one. This is 67. And then I would do plus 12 again to get my second standard deviation. That would be 79. And then I'll do plus 12 again just to get my third standard deviation. So I have all of my positive ones by just doing plus 12. So how I do the other one is I just do 55 minus 12. I get 43. And then I go minus 12 again. And I get 31. And I subtract 12 again to get my third standard deviation and say 19, okay? So most people should fall between this 19 and 91 on that score, right? So if I want to know specifically what's between 43, I'm going to highlight that, 43, and 67. Well, it looks like that's one standard deviation on each side. So we've got the 34.1 plus 34.1. which gives us the 60. Oh man, that's really fat. Let's go erase this. This is where we need to just make our number, our line thinner again. Okay, so we get a 68.2%. Okay, so 68% of the people fall between this 43 and 67%, right? That's what the Z-score allows you to do. It allows you to find specifically, okay, where does somebody fall, right? What percentage of people are in this set, right? So you can also use it to find out specifically, okay, well, how many people are eligible to get this, like, what is important for this agency, okay? So an agency in the state only hires people with test scores of 67 or greater. So we did this, our numbers up here, and we found out that 67 was 1 standard deviation away. So I'm going to go to that 1 standard deviation. And then it says, or greater. So I know I'm going like this. I'm saying anything more than 1 standard deviation. What percent of people have test scores that make them eligible to hire? So all I would do is I'd add up those 3 numbers. I do 0.1 plus 2.1 plus 13.6, and I'd get the 15.8. So they only hire the top 15.8% of people that are in, that take this test, right? Now, a lot of companies do this based off of their tests. They say, okay, well, this is our normal distribution is between this, like this is our mean, this is our standard deviation. What percent of people are we actually comfortable with hiring, right? So this agency said, okay, well, I want the top 15%, right? That means they would have to be above 1 standard deviation away from the mean, right? It's kind of a good way of picking how or what percent of people that you want to hire and kind of giving standards for different companies, right? All right, so again, you're gonna have questions that look like this as well, where you have to find out what they're asking for. So if I just say P of X is greater than or equal to mu, what I would do is I'd say, okay, well, here's the mean. If I want anything less than, sorry, this is a less than symbol, less than or equal to it, I would just add up all of those numbers. And if you add up all of those numbers and you're talking about mean, you should get 50%, right? Okay, so second one, I'm going to erase this line again. I'm going to switch over to green, I think, just because I think doing different colors might help, right? So now this one says X has to be between, it has to be greater than mu, so I'm going to put my line at mu, but less than or equal to positive 2. So all I would do is have to add up those numbers. So that 34.1 plus 13.6, and I get that 47.7%. Okay, if I wanted to do this one, this last one is less than -3 standard deviations, what I would do is I'd go to that 3 standard deviations, and if I talk about less than, it means I'm going towards the left, and I would say that's 0.1%. So what's the probability that somebody scores lower than 3 standard deviations? 0.1. All right. Now, this works and all for people who are like specifically at those numbers, right? We only know specifically 1 standard, 2 standard, and 3 standard deviations, but we've gone a lot further than that, okay? We've taken this normal curve and said, okay, well, what if they scored a 52? Like, where would that fall on the graph? If our mean was 55 and our standard deviation was 12. So that would be 67, right? What if they only, or not 52, what if they scored a 57? Where would that represent? Okay, now this is how, using a normal curve and something that works on a normal curve, we get something called a Z-score. Now, z-scores help us find percentiles. Okay, so when they say, oh, you're in the 95th percentile, what that means is that you scored 95%, like you were in the top 95, right? How they get that is they use your z-score. So if you want to pause the video and write down this equation, that would be really helpful for you. A z-score, all you have to do is take x, your value. So if I wanted to know what 57 was, I would say 57 minus mu, my mean, 55, divided by my standard deviation, 12. So I would do that in my calculator, and I would get 0.166. Now, a lot of you are probably thinking, well, that doesn't make sense. They're not in the 16th percentile. They're above 50%, right? This isn't their percentile. This is their z-score. You still have to go to a z-score table. So I have that PDF for you in this section. So you make sure you do know that you will have to use that. But this is that z-scores table. So if I'm going to go to my z-score that I wanted, what did I get? I got 0.166. So what I would do is I would say, okay, well, 0.166, that's 0.7, right? So I'm going to that 0.7, or actually, I can go, no, I'm sorry. I should go to 0.1, right? 0.1 and then 66. So that means that this second one should be 0.17. So I'm going to go right here onto this 0.7, 0.7, and 0.1, and I'm going to find that value is right here. Okay, so what this is saying is you're in that 56th percentile or 57th percentile because your z-score is 0.56749. Okay, I know it's probably really small on here, but you will have this chart, this exact chart I will post on Schoology for you as well, for you to use with your z-scores. I'll probably screenshot the parts that you need on the problems, but we'll see how creative I can get. All right, so the study finds that the weights of the infants at birth are normally distributed. The mean is 3,270 grams, and the standard deviation is 600 grams, and an infant is randomly chosen. What is the probability that the infant weighs 4,170 grams or less? Okay, so this, they're saying it's normally distributed. They're giving you mu. They're saying, okay, your mean is the 3,270. They're giving you the standard deviation is 600, and they're giving you the value that they care about. They're giving you the infant's value, okay, in grams. So here we are, and we want to know how many grams or less. Okay, now this is the thing about z-scores. They always tell you how much or less. So if you want to do or more, you're going to have to subtract. So this one's still doing or less, so that's perfect. What we're going to do is we're going to fill this in. We're going to do that 4,170 minus the mean, which is 3,270, divided by your standard deviation. And I'm going to calculate that. I'm going to grab a calculator. I'm going to type that in and get my z-score. So I've got that divided by that 4,1. Oh, I stink. It's not 4,100 divided by the standard deviation, which is the 600. I was like, that doesn't make any sense. 600. And I get my answer as 1.5. Okay, that's my z-score. So what I'm going to do is I'm going to go to this z-score table, pull this back up. I'm going to zoom in so maybe you can see this a little better. Okay, so I want to go to 1.5, and it was straight up 1.5, so I'd want to use 1.500. So this extra one is just your like second and third decimal. So 1.500, and I get this number, okay? So what is the probability that they score here or less? If you're at the 1.5, you're 93% percentile, okay? So 93% of the time, 93% of the time, you would find a baby that weighs less than or equal to that 4,170 grams, right? They're in the 93rd percentile, if that's what they're at. It's kind of cool, huh? Okay, so this is what you're going to be doing in your assignment today. You're going to, on Monday, sorry, you're going to be finding what percentile they're in just on a normal distribution, and then you're also going to have to find some of that z-scores where you're finding the percentile or how many grams or less are they at. Like, what's the probability of getting a data point that's in here? So I hope you guys have a good day. If you have questions, please let me know. I will post a few like Khan Academy videos about z-scores and normal distributions because I know this can be a little tough. So this is really the hardest section for this chapter. But I do think it's really important for you guys who are planning on going into AP Stats. So, again, if you have questions, let me know. Have a nice day.